Okay, the second question that's come in also relates to homework number 3 in problems like 35, when it boils down to something like the limit as x approaches negative infinity of 10 over x. I don't understand how that becomes 0, which is a pretty specific question. But since I have you here, and since I'm trying to do this, I'll try to talk through the whole problem, and then maybe also 36 here, which is a comparable problem. So here we go again. So first off, we have a limit, and it so happens to be at infinity. But it's what's the limiting value as x approaches negative infinity of this whole sum here. And whatever this equals, it's going to be equal the contribution of this piece plus the contribution of this piece. So one of the things we're going to do early on is use a limit property and say, well, what is that first piece trending towards? And that's this right here. What's the limit as x approaches negative infinity of the 10x over x squared piece? And we're going to add that to the contribution of this second piece, and that's this term. That's this expression right here. And then we'll use end behavior models because we're at infinity, and we don't really have to do any simplifying over here. 10x over x squared is just going to become, well, we don't have to do an end behavior model. I should have said 10x over x squared is going to simplify to 10 over x. Here we do have to do an end behavior model. So when x gets, if I go back to my number of x is 1,000,000, this is basically going to be 3 trillion plus a little bit, and this is going to be 1 trillion minus a little bit, and basically 3 trillion divided by 1 trillion is going to be 3. So that's what happens right here. This we're gonna end behavior model this to get this guy right here. We're going to cancel the x squareds. And the limit as x approaches negative infinity of 3 will be 3. Now we'll get to that specific question. All right, so we have the limit as x approaches negative infinity of 10 over x. To me, the simplest way to think about this is just, well, okay, what's 10 divided by the biggest number you can think of? It's basically 0. 10 cookies shared by the population of the planet, you basically don't get anything at all. You get some microscopic cookie dust. So it's basically nothing. If we wanted to up our game a little bit here, we could. Oh, let's see if I can do this in this. I'm just drawing this with my finger, so it looks pretty crude. But if we think of that y equals 10 over x is a function of the form y equals a over x. It's just a vertical stretch of y equals 1 over x, and y equals 1 over x looks like it's not too bad, and it looks like this. So if we take that graph and we say what happens as x becomes increasingly negative, what's happening to this height of the curve? Well, the height of the curve is hugging in towards the x-axis, and it's getting closer and closer and closer and closer to 0. Theoretically, it never gets to 0, but it's getting closer and closer and closer to 0 as you divide those 10 cookies by all the stars in the night sky, or whatever your surrogate is for insanely big number. So 10 divided by the biggest number you can think of, and the fact that it's negative doesn't change the fact that it's approaching 0. It's just approaching 0 from the negative side. So that's where that 0 comes from, and basically 0 plus basically 3 is a number that's cruising in on 3. All right, while I have you here, 36 is the exact same kind of idea, although except for the limit of an expression that has something plus something. Now it's the limit of an expression that's something times something. And what's this going to equal? Well, let's figure out what this piece is going to become way out to the right on the x-axis. Let's figure out what this term is going to become way out on the right on the x-axis, and let's multiply those together. All right, what is this term going to become? Well, that's the limit of 5x squared over x squared minus 1. What's this term going to become? Well, that's the limit as x approaches positive infinity of 4 plus sine of x over x plus 1. So we'll figure out this piece first, way out at positive infinity. We really don't have to do any end behavior models. 5x squared over x squared will become 5 minus 1 will stay minus 1. So it doesn't matter what x is. If x is 1,000,000, you got 5 trillion divided by 1,000,000,000. That's 5 minus 1. And 5 minus 1 is going to be 4. And where I think people had trouble on this, I bet it was with this term. It's a multiple choice question, so I can't tell where you go off the rails. This one had, as we can tell from the bright color, this one had a pretty high miss rate. All right, so as x approaches positive infinity, what's happening to this piece right here? Well, the denominator is becoming 1 bigger than the biggest number you can think of. So the bottom number is blowing up. And the numerator here is just piddling around between -1 and 1. So if I say not much, something between -1 and 1, divided by 1 more than all the stars in the night sky, what is that? Well, it's nothing. It's basically nothing. Maybe it's nothing. Maybe it's really close to nothing. But it's just nothing. So this piece is going to 0. And 4 plus 0, as a math teacher, I'm going to tell you that's 4. So the limit as x approaches positive infinity of 5 minus 1 is 4. The limit as x approaches positive infinity of 4 plus 0 is 4. And my final math teacher move here will be to say 4 times 4 is 16. And there it is.